Hello, everybody. Today, we are bringing you this session to talk about enhancements, innovations, and security features that we've introduced for Active Directory certificate services. My name is Tanya, and I work as a product manager on Active Directory, working on the feature development, servicing, and delivery related to Active Directory domain services, certificate services, federation services, etc. And along with me, I have my colleague.
Hi, my name is Thirunadha Reddy. I'm a principal software engineer on Active Directory team. I've been with Microsoft since 2007, working on Windows OS components. For the past 10 years, I have been in the identity and security space, focusing primarily on ADCS and ADFS.
So, moving on, as we walk through today's agenda, we have 4 different features and areas that we want to talk to you about, starting with CRL partitioning. What is it and what do we have for you? We also want to bring our 4 KB extension and beyond, which talks about enhancing that limit for you all, securing ADCS with enhanced audit events, as well as hardening, what to do and how to do it. And then we talk to you about a few more updates that we would want to share about all these different features today. So let's dive right into it. And starting with CRL partitioning with Windows Certification Authority. Now, before we dive into CRL partitioning, let's revisit a few things related to certificates. So what are certificates and why do we need certification revocation? So to begin with, certificates, as we know, have clearly defined validity periods that start from valid from to valid to dates. Sometimes these certificates become invalid before expiration due to factors such as key compromises, employee turnover, or changes in data. So here is where certificate revocation lists come in. Certificate revocation lists are digitally signed files issued by certificate authorities to inform systems about these prematurely revoked certificates. Each entry contains critical details such as serial number, revocation date, and reason for revocation. So these are lists that are published periodically and can also be published on demand as and when the certificate admins want to do so. Now, we primarily have 2 different types of certification revocation lists. We call them base CRLs that are published every 7 days and delta CRLs that are published every 24 hours and only contain certificates revoked since the last base CRL publishing. So your base CRLs are going to have information about all the revoked certificates, wherein your delta CRLs will have the information of all the certificates that have been revoked ever since. Now, while we have these 2 different types of CRLs, there's a big challenge with having large CRLs once we start having a number of certificates that start getting revoked. These result into critical scalability challenges, which impact download speeds, which slow down our certificate validations, and even to check one certificate validity, the client machine has to download the entire CRL. And to make matters trickier, you cannot introduce CRL splitting after certificates have been issued. So this demands careful, proactive processing and planning. That's exactly why we've built CRL partitioning feature. By intelligently dividing large CRL into streamlined partitions right from the start, we dramatically enhance efficiency, enabling client machines to only and quickly download the specific partitions they need, greatly improving validation performance. And to talk more about CRL partitioning and how that feature works for you all, I would like to pass it off to my colleague Thirunadha, who will now take us through a live demo to see how the feature works.
Thank you, Tanya, for the great introduction on CRL partitioning. I'm going to demo the CRL partitioning feature. First, let me talk about the lab setup I have. I have a CA issuing web server certificates. It is currently set up to publish both base and delta CRLs. And if we look at the base CRL, it currently has only 2 entries, but this list can grow substantially large when there are multiple certificates revoked for any reasons. Now let's look at the CDP extension settings. I have a local folder selected for publishing both base and delta CRLs. There is nothing selected under LDAP. And I've selected to include HTTP URL in both precious CRL location and IDP extension. We also selected to include it in the CDP extension of issued certificates. Now, if we look at the CDP extension in any of the issued certificates, it will have the HTTP URL configured after replacing all the variables names with the actual values. What this means is whenever an application receives this certificate, it will first download the base CRL from that location, and from the base CRL, it can get the delta CRL by using the freshest CRL extension value. Once it has both base and delta, it can determine the revocation status of the certificate. We also need to make this URL available to clients. So what I've done is I installed IIS on the CA, but of course this is not recommended on production for security reasons. I've also created a certain role virtual folder. This is currently pointing to the same physical location where the CRLs are being published. Now let's look at the configuration changes required to enable the feature. First thing is we need to include the CRL partition index variable. I've included that here. Let me update this value in the CDP extension settings. I'll unselect both the checkboxes for the existing value so that it will no longer be used. I will add the new value and select the same checkboxes. I will do the same change for HTTP location as well. I'll restart the service once I'm done with all the changes. The next step is to set this particular bit in the CRL flags registry. I'll also configure the CRL max partitions to 10. Now I'll restart the service. I'll also publish the CRLs. Now if we look at the CRLs, there will be several CRLs published, one base and delta for each partition. So we see one base and delta for partitions 1 through 10. We also have the previous base and delta CRLs. They continue to be generated and they will contain the revocation status of all the certificates. We selected this approach so that services like OCSP, they continue to work even if they are not aware of the partitioning scheme used at CS. You can change this behavior by setting another bit in the CRL flags to make the partition 0 CRLs non-cumulative. And if we look at the CRLs generated, the freshest CRL extension, that variable will be replaced with the actual partition value. For partition 1 CRLs, we see partition 01. We see similar change in the IDP extension as well. Now let's go ahead and request a few certificates. I'm going to request 3 certificates. We have also added a new column called CRL partition index to the database. So let me add that column here. So these certificates, they are assigned to partition 2, partition 10, and partition 4. Now if we look at the CDP extension of these certificates, they will have a URL of the corresponding partition CRL. So you see partition 2 here, and similarly for partition 10, we see underscore partition 10. Now let's go ahead and revoke one of the certificates. I will revoke the certificate that's assigned to partition 2. Now I will publish the CRLs. We have also updated the UI to show the CRLs of all the partitions. So if we look at the view CRLs UI here, CRLs of all the partitions. And let's look at the CRL of partition 2. It has the revoked certificate information, but the other partitions won't have this except partition 0 because this is maintained as a cumulative CRL. We also support a number of other configurations. Apart from the CRL max partitions, you can also suspend some partitions, the lower range of partitions, by setting this registry key. And as mentioned before, we can make the partition 0 CRLs non-cumulative by setting this particular bit. And we also support the round robin assignment of partitions. So we need to set the partition index in this registry And we also updated the published CRL APIs. Now these APIs will publish the CRLs of all the partitions. We have also added some new properties under get CA property to be able to download the CRLs of all the partitions and their status as well. And you need to pass the partition index in the higher 2 bytes and the key index in the lower 2 bytes to download the CRL of any partition. For example, for partition 4 and key index 3, you need to pass the value as 0x40003. That concludes the demo. Thank you.
And now, as we move out of that topic, we walk into our next big feature, which is something that's less known, has been around for quite some time, but is still very critical. And that's why we want to call it out. So let's talk about certificate extension size limit. As you all know, that Active Directory Certificate Services has a default extension size limit, which is a 4 KB cap that is placed by the certificate authorities. Now, this is good for most scenarios, but can often cause issuance failures, especially when you're working with SAN extensions that include a large number of entries or custom certificate extensions that are larger in size and often exceed 4 kilobytes in size. So whenever you run into these scenarios, you will typically run into errors such as jet error column too big in your certserv logs. Now, in order to really mitigate this situation, as you can see right now, the extension raw value currently has 4096 bytes. But to accommodate more and more customer scenarios that have come to our attention, now we allow you to expand the extension size limit to 16 kilobytes. This requires you to first download the necessary Windows updates to enable the expansion, which you can find at aka.ms cert extension limit. Following that, you will need to make a registry change where we add the 0x1000 bit mask to the DB flags registry key and restart the certificate service for the changes to take effect. A critical note. This change is irreversible, and you would need to apply this change to all the certificate authorities server that requires you to extend the database. So essentially, you would want to make sure that if you are running into this scenario, you do this with a lot of care and precision. And once enabled, you will see that the extension raw value has now increased from 4096 bytes to 16384 bytes as shown in the certutal output. This unlocks support for more complex scenarios without hitting that restrictive size ceiling. Moving on, I will hand off this next section where Thiru will talk about how do we enhance our security when it comes to AD certificate services through enhanced audit events. Over to you, Thiru.
Thank you, Tanya. Now let's take a look at a few enhancements we have made to CA audit events. As many of you are aware, CA audit events are critical for tracking certificate issuance activity and maintaining the security of PKI. They help us detect misuse, support any investigations, and to maintain compliance. All the CA audit events are documented in our PKI security guide. We have enhanced 4 key events, 4886 through 4889. 4886 is logged when a certificate request is received. 4887 is logged whenever a request is approved. 4888 when a request is denied, and 48889 when a request is put in a pending state. This table shows you all the fields that are currently logged in these audit events. These audit events will now have additional fields which will help you to understand what is really being requested, how, and who are requesting those. Let's talk about the enhancements specific to event 4886. This event now includes any subject and the subject alternative name fields, alternative name extensions from CSR if there is any. We are also logging the template name coming in the request. We have also provided fields to log details about the client submitting the request, things like the client's OS version, the cryptographic service provider used to generate the key pair on the client, and some additional details about the client, like the mission name and the process name that generated the request. These fields are populated based on certain attributes coming in the request, so they should not be used to make any critical security decisions. Now let's move on to 4887, which is logged whenever a certificate is issued. This event now includes a SAN and a serial number of the issued certificate. We are also logging the template name against which the certificate has been issued. We have also added a few common fields across 4886 through 4889 to give more context about the transport mechanism used by the client. The authentication service tells you how the client was authenticated, like whether it used NTLM or Kerberos or S-channel. The authentication level shows the level of protection used on the request. And finally, we also capture whether the request was submitted using DCOM or RPC-based protocol like MS-ICPR. This slide shows a side-by-side comparison of the old existing event and the enhanced event. On the left, we have the existing event, which has very basic information like request ID, requester, and few attributes. On the right, we have the enhanced audit event. This now includes the fields like subject alternative name from CSR, the template name, and the voice version of the client, the CSP provider, and the mission name and the process name that generated this request. For this particular example, I used a CertRec tool to generate a request as test1 user, but I specified the subject and the subject alternative name as administrator. And that is what we are seeing in the event. The request was submitted over DCOM using Kerberos authentication, and the authentication level was set to privacy. And the next slide shows you the event 4887. The difference here, we have the subject alternative name, the template, and also the serial number of the certificate. And the authentication service and authentication level, they are same as the event 4886. Now let's look at a few practical ways these new audit fields can help you detect any misuse, stay secure, and track certificate request and issuance activity. Let's start with the template name, which is now available in both 4886 and 4887 events. Once you know which templates are published on your CAs, you can set up alerts for any incoming requests with templates names outside that list. This way, you can catch any unexpected template usage. Similarly, you can create alerts for rarely used or high privileged templates, such as domain controller or enrollment agent certificate templates. You can also combine template name with other fields like requester to make sure those templates are only being used by the account that you would expect. And with the help of subject and SAN in 4886 and 4887 events, we can create alerts for high privileged accounts such as domain administrators or domain controllers at both request and issuance stages. A mismatch between these values in events 4886 and 4887 can signal a failed attempt to obtain a certificate for a privileged identity, as we saw in the previous events. The authentication service field tells you how the client was authenticated, typically NTLM or Kerberos. You can use this to identify the clients that are still using NTLM and plan for deprecation of the same. The client info fields help you see the OS version and the client processes requesting certificates. They also give you a way to build usage analytics, track client distribution, and spot anomalies like outdated systems or unexpected sources. But just keep in mind these values are provided by client. So while they are great for analytics, they shouldn't be relied on for security decisions. To wrap it up, these enhancements turn CA audit events into a much more powerful tool, not just for compliance, but for actively defending your PKI. They help you to detect misuse, monitor request and issuance activity, and get a clearer picture of what is happening on your CAs. Now let's talk about a few key areas that PK administrators should be focusing on to enhance the security of their certificate authorities. It is really not possible to cover all aspects of CA hardening in a few minutes, but I will try to highlight some of the most important areas based on recent security incidents and the feedback from security researchers. These are practical, high impact steps that you can follow to improve the security posture of your PKI. Let's start with why the security of CA matters so much. CAs are at the core of organizations' trust infrastructure. The certificates they issue secure critical operations like smart card logon, VPN access, Wi-Fi authentication, and code signing. If a CA is compromised, it can issue credentials trusted for any identity or service, essentially letting an attacker impersonate as anyone. Simple misconfigurations can often lead to more serious security issues like domain escalation, especially with overly permissive templates or access control lists, credential theft, and MFA bypass, since certificate based authentication is often considered sufficient for MFA. Persistence and stealth access using valid long lived certificates. This is why CAs are considered tier 0 assets on the same level as domain controllers. They need to be isolated, protected, and monitored accordingly. One foundational step is protecting your CA's private keys, ideally using a hardware security module or HSM. In the next few slides, I'll walk through some specific areas where PKI environments are often exposed and what can be done to harden them. The first one is certificate templates, because this is where a lot of problems start when not configured properly. Certificate templates are often set up quickly just to get things working, with overly broad permissions granted to large groups like authenticated users or domain users, even on sensitive templates. While that might seem convenient, it opens the door to domain escalation attacks. To avoid this, assign permissions only to specific accounts or tightly scoped custom groups. Another problem is templates that are no longer needed but still published. Make sure you are only publishing the templates that are currently needed. Unused or legacy templates should be removed. Keep rarely used ones like enrollment agent or key recovery agent only when actively in use. It is also a good idea to prevent the default templates during CA setup by setting this setting load default templates equal to 0 in CA policy.inf file. And a more serious risk comes from the templates that use the supply in request option for subject. It lets the user decide what subject or SAN to put in the certificate, which can lead to impersonation if not controlled. This setting should only be used by privileged accounts, such as ideally with extra checks like manager approvals, authorized signatures, and tight monitoring. As we covered in the enhanced audit topics, the audit events 4886 and 4887 now include the template name, subject, and SAN details. These enhancements should help you detect any certificates issued to high privileged accounts. And after template misconfigurations, NTLM relay is another risk to be aware of. Let's take a closer look at that next. NTLM relay attacks are a concern, particularly in environments where ADCS HTTP endpoints are exposed. When not protected, attackers can relay NTLM authentication from a user to HTTP endpoints like CertSRV and request a certificate on their behalf. We published mitigation guidance in KB 5005413. The key steps include enforcing HTTPS on the CA web interface, enabling extended protection for authentication, and disabling NTLM where possible, especially on servers hosting ADCS or other critical infrastructure. Most of these protections are already enabled by default in newer server versions like Windows Server 2025. Now let's look at another key security aspect, strong certificate mappings. In May 2022, we released fixes for Kerberos Key Distribution Center and certificate authorities to address elevation of privilege vulnerabilities. These can occur when a low privileged account are able to obtain certificates for high privileged accounts by spoofing Active Directory attributes. To prevent this, KDC uses something called strong certificate mappings. These mappings allow KDC to verify that the certificate was actually issued to the account that is trying to authenticate with the KDC. There are two ways to establish these strong mappings. One is manually using the All Security Identities attribute. The other is by having CA include the security identifier or SID as an extension in the certificate itself. CA can add the SID in the certificates issued against online templates, but for offline templates, the SID information needs to come from the enrollment agent or registry authority for the CA to be able to include it in the certificate. The full details about strong mappings are documented in KB 5014754. These fixes are enforced by default as of February 2025. If you have not created any compatibility registry keys, as mentioned in the KB, then you are already in a good position from security point of view. However, if you have set any of the compatibility keys, then you should plan to remove them as soon as possible to be able to protect your PKI from domain escalation attacks. There have been updates from ADFS and Intune related to these changes. ADFS can act as the registration authority in certain Windows Hello for Business scenarios, and you need to run the command let set ADFS certificate authority enrollment agent add certificate extension to true, so that the certificates issued will have the SID extension included. And Intune released some fixes for PKCS profiler. The connector will now include the SID extension in the certificates, and the SCAPE profile SID info will be added as an alternate name in SAN extension. So that covers the strong certificate mappings and the recent changes to certificate authentication on domain controllers. Let's wrap up with a quick summary and a few key action items. To summarize, CS are tier 0 assets and must be secured and protected accordingly. Start by reviewing and hardening your certificate templates. Remove unused templates and restrict permissions. If you have installed ADCS role services with HTTP interfaces, review your NTLM settings and apply the mitigations from NTLM KB. Strong certificate mapping is now enforced by default. If you are still using compatibility registry keys, aim to remove them on priority. Each of these steps helps reduce the attack surface and strengthen the overall security of your PKI environment.
Thank you so much, Thiru, for walking us through the different steps we should take to harden our AD certificate services and make it more secure for everybody using it. So now that you all know that we have such interesting things coming up for you all, let's talk about where can you check them out and how soon will they be available. So your enhanced audit events are already available in Windows Server 2025 and any vNext preview builds. We are also slowly rolling out the changes to Server 2019 and later in the coming few months. Your CRL partitioning feature is currently available in vNext preview builds, and you will soon be seeing it for all the other OSs starting from Windows Server 2019 to 2022 and 25 in the coming few months. So please keep an eye out for these changes as they come in. And strong certificate mapping, an important reminder about it is to ensure that your compatibility mode, because it will be removed, it is only going to remain until September 2025. So ensure that you make the necessary changes in order to prepare for that. And with all of these call to actions, we would like to wrap up our session. And thank you so much for listening to us. And we hope you go back and check out these new features. Thank you so much.